So this is the Atwood machine, M1 and M2. M2 is greater than M1. M2 goes downward, M1 goes upward. They both have the same magnitude of acceleration. You want to find the acceleration and also the tension on the rope. So how many forces are acting on each one of these?
Tension and G.
Tension and weight. So this one has M1G acting on it and tension on above. And the same tension applies here. And the weight of this one is M2G. Right? So we draw a free body diagram for each one of these and apply Newton's law. So for M1, let's take this as X and Y, and the forces T and M1G, and the acceleration is up. What does the Newton's law say? It says sum of Fy equal to MAY. Sum of Fy means T minus M1G equals to M1 times Y component acceleration is the same as magnitude, so just A, because A is up. So this is one equation. And do the same thing for the other one. So if this is M2, X direction, Y direction, and you have tension force, the same magnitude, because, and this is M2Y. So that the tensions are the same because the pulley is massless and frictionless. So tensions are the same, the accelerations are the same, but the acceleration for this one is in negative direction. So sum of Fy equals MAY again. Sum of Fy means T minus M2G equals to M2 times Y component of acceleration, which is negative magnitude, negative A. And if you multiply by negative sign, you get M2G minus T equal to M2A. And this is the second equation. We need to eliminate T or A to find the other one. We eliminate T first. If you add the two equations, T will get eliminated, right? So you get T minus M1G plus M2G minus T, T minus M1G plus M2G minus T equals to M1A plus M2A. Now, if I cancel the T's, and here we can write the other way around, M2G minus M1G equal to M1 plus M2 times A. I want to make a little observation here. Although we have Newton's law for one object at a time, but when you write for two objects that are interacting through this tension force, see there's a tension that is between them. This tension force, if you consider both of them as one object, is like an internal force that cancels out. But then what you get is the Newton's law for those both of the objects together. You see, if you consider both of them together, M2G is the weight of this one that is pulling this way, M1G is pulling the other way, and net force acting on these two is M2G minus M1G. And that net force is equal to the total mass times the acceleration. You can look at it this way. You see, M2G minus M1G is equal to total mass times acceleration. So that's Newton's law for the two objects together. If you have enough understanding of Newton's law, you could do this right away. Say, okay, there's a force this way, there's a force the other way, net force equal to total mass times acceleration. That's this. And then if you want to find acceleration, you say M2 minus M1 over M1 plus M2 times G. And now we can plug in numbers for M1, M2, and G and get acceleration. And then Now that you have acceleration, you can use any of these two to get the tension. If you use the other one, the first one, and T equals to M1G plus M1A, and A, put A equal to that, T becomes M1G plus M1G times M2 minus M1 divided by M2 plus M1. And you see M1G can be factored. M1G times 1 plus M2 minus M1 divided by M2 plus M1. And you write this 1 as M2 plus M1 divided by M2 plus M1. Take the common denominator. T will be M1G divided by M1 plus M2. This becomes M1 plus M2 plus M2 minus M1. M1 cancels, get 2M and 2. And then we can write it as this 2M1 M2 divided by M1 plus M2 times G. Now we can look at the limiting cases. What do you expect if N1 and M2 are the same? Without looking at the equations.
They wouldn't move.
They wouldn't move. The acceleration should be 0, right? Look at this. If M1 and M2 are the same, it gives you 0 acceleration. What do you expect the acceleration to be if M1 was 0? Don't look at the equation. If M1 was 0, what would be the acceleration?
That would just fall.
It's just, this would do
It would
free
be
fall. A would be equal to G, right? If M1 is 0. So put M1 equal to 0. Get M1 is 0, 0. Get M2 divided by M2 is 1 times G. What do you expect if M2 was 0?
The other one.
Yeah, go the other way, right? So A will be negative G. So you put M2 equal to 0, get 0 here, negative M1 over M1 is negative 1 times G. You see, it works every which way. And what do you expect for the tensions if M1 and M2 are the same? If M1 and M2 are the same, they will balance, right? M1 and M2 are the same, they will balance. What would be the tension? Is equal to the weight of one of them, right? It doesn't give you that. Put M1 equal to M2 equal to M. You get 2M times M divided by M plus M. 2M squared divided by 2M. 2M cancels, get mg. The tension becomes mg. If either of these is 0, what do you expect the tension to be? If one of them is 0, it makes no resistance. The other one falls. What would be the tension?
What was the question again?
If one of them is 0, well, let's say M1 is 0.
Then
What is the tension? There will be 0, right? Because there's no resistance here. This will fall, free fall, and there's no tension. If you put M1 equal to 0, you get 0. If you put M2 equal to 0, you get 0 again. Right? But if M1 is equal to M2, T becomes one of the masses times G.